Hello everyone. In this presentation, we are going to discuss about the non-preemptive nature and how to come out from the non-preemptive nature in an entry-exit system, or we can call it as volume up, volume down system. So in a TV remote control, there is a volume up button and volume down button. So this application can be used as an entry-exit system or volume up or volume down system. So here there are 4 tasks involved, as we know. One is your main routine, external interrupt 1 which decrements the count, timer ISR which refreshes the screen, and extra interrupt 0 interrupt service routine to increment the count. So as discussed several times, the main routine runs because timer interrupt comes once in 8192 microsecond, go to ISR, completes ISR, come back, and again continues in main routine after again another 8192 microsecond. Why? Because timer 0 and 13-bit timer mode is used here. So once in 8192 microsecond, it goes to the timer ISR, which is periodic interrupt service routine. By the time of executing the interrupt service routine, timer 0 interrupt service routine, if I press the entry button, even though if I press the entry button, because of non-preemptive nature of 8051, it will wait until the timer interrupt returns, and once it returns, it goes to the ISR and increments the variable, and then come back to the main routine, and it continues. So what we did was, in the decrement, that means in the external interrupt 1 ISR, while decrementing the count, we have made the system to hang, and the code will never return from the interrupt. Because the code has never returned from the interrupt, all other highest priority interrupts, say for example after 8192 microsecond, timer will keep on overflowing, and whenever I press an entry switch or whenever I press an exit switch, all the interrupts will be pending. Why? Because of non-preemptive nature of 8051. Until it returns from the external interrupt 1, other highest priority interrupts will not run, you can see here. So because it is while 1, it will never come out from the interrupt service routine. That means it will never return from the interrupt service routine, so the system gets hanged. So to prevent this, we are going to use a watchdog timer here. So this is one application of watchdog timer, where in the external interrupt 1, we predict that there is a possibilities of hanging of system, and here we enable the watchdog timer to overcome this. So after 8051 watchdog timer is a 13-bit timer. So after enabling, it will wait until 8 milliseconds, that is 8192 count. Each count is 1 microsecond, means it will wait for 8192 microsecond, and it overflows. When it overflows, it will reset the microcontroller, and then the other functions will work perfectly other than the decrement function. So when compared to this particular non-preemptive nature, when it hangs, this using the watchdog timer will help us to prevent the hanging of the system because of non-preemptive nature of 8051, where we can understand the non-preemptive scheduling as well as the watchdog timer preventing the hanging of the system in this experiment. So let us see, for example, in this code, in this board. So this is the entry switch which is connected to the external interrupt 0. This is an exit switch which is connected to the external interrupt 1, which is configured as edge triggered mode. So now I am pressing the entry switch. So it is entry switch or volume up. It is keep on incrementing the volume. When I decrement, because I have written the while 1. When I decrement, because I have written the while 1 inside the decrement code, it gets hanged. When it hangs, the other highest priority interrupt for display refreshing will not run. So the display will not come. So display will go off. When I increment, it will work fine. But when I decrement, display goes off. Then whatever key you press, it will never work. Only when we reset, the display returns back, and then again increment. As long as increment, everything will working. When I press the decrement, it goes to the while loop, and then it hangs. Due to the non-preemptive nature of 8051, extra interrupt 1 will never returns. So even though timer 0 interrupt is having highest priority, it will never refresh the screen, etc. It goes on. So to come out from this, we are going to write a watchdog timer. We look at the code now. With respect to 8051, we are using the watchdog timer. So in this code, if you see, we are initializing the watchdog timer by using the SFR watchdog timer reset. Okay, so the enabling the watchdog timer, the watchdog timer special function register location is A6 location, which is watchdog timer reset, which is being initialized, which is in the special function register area. So from the datasheet, watchdog timer location is 0xA6. And as told, as we see in the external interrupt 1, in the external interrupt 1 we are decrementing the variable, and then purposefully we have hanged the system. But we are interested to enable the watchdog timer. Now we are interested to enable the watchdog timer by writing the code. Watchdog timer reset is 1e e1, which is the syntax for starting the watchdog timer. So when we give the sequence of 1e and e1 with respect to 8052, the watchdog timer will get enabled. So even though the system hangs, because the watchdog timer is enabled, it will reset the system automatically after 8192 microseconds, which prevents the hanging of the system. Non-preemptive nature of 8051 is overcome up to some extent, and the application will run perfectly. This we can check it in the simulator first, and then we can go to the hardware, and then we can test it. To test it in the simulator, if you see, when I run this code, it keep on running, and P3.2, in P3.2 I am just pressing the entry switch. Whenever I am pressing the entry switch, just keep on incrementing. If you see, here you see there is a count says 5. So thousands, hundreds, tens, ones, 1 says 5. So every entry increments, but every exits it has to decrement, but it becomes 0, and because of the watchdog timer, you see c equal to c minus 1, you can see watchdog timer has started. Now I do the single step execution, watchdog timer is keep on running. Now the watchdog timer shows 46, 47, 48, 49. This is the watchdog timer. You see the screen, watchdog timer is enabled, it is counting. You see, now I am doing the single step, it is counting, watchdog timer is counting here, you see 84, etc. So when I run this, watchdog timer will overflow, and then it will reset the microcontroller, etc. So now I press this button, it comes out from the ISR, and when I run this code, it works fine. So now coming to the kit, we can experience it very clearly. In this kit, the code is downloaded. Now I am downloaded with watchdog timer enabled, right? Now 1, 2, 3, 4, 5, 6 entries happening. When I press the exit switch, even though while 1 is there, it will hang, but watchdog timer will overflow and then reset the microcontroller, and the whole system will reset if I press the exit button. You can see whole system has reset. So now the timer function is not disturbed, so display is not getting disturbed. So due to the presence of watchdog timer, even though system hangs in the exit code execution, because of watchdog timer, it resets and makes the system to function properly automatically. This justifies the non-preemptive nature of 8051 is overcome with the help of watchdog timer up to some extent in this particular experiment. So entry, it increments. When we press exit, even though it hangs, watchdog timer overflows and then resets the controller to bring it to the normal function. That is what we have to understand from this experiment. Thank you.